With that overview of pthreads, let us now get started with introduction to concurrency. Since we are talking about multi-threaded programming, it is important for us to understand how the instructions within a thread and across the threads are expected to execute. First, let's recall how statements are executed within the traditional single-threaded processes. So let's assume we have this classic process P1 and it has these three statements S1, S2 and S3 in this program order. Assuming there are no jumps in this program, you would know that these statements S1, S2 and S3 would be executed exactly in this sequence, in this order as stated here. The order in which these statements or instructions are executed is deterministic. Now let's see what happens for a multi-threaded program. Let's assume we have a process that has two threads T1 and T2. Inside thread T1 we have two instructions A1 and A2, and inside T2 we have two instructions B1 and B2. Let's again assume there are no jump statements here, and therefore within a thread, let's say if you're looking at inside thread T1, the statements are executed in program order. So within a thread it is guaranteed that first A1 would execute and only then A2 would execute. Similarly here in thread T2, first B1 would execute and after that B2 would execute. So this is deterministic. However, the problem is the order in which the threads are scheduled, that is not determined by the programmer. That is determined by a thread scheduler or by the operating system. Also, we do not know when a context switch will occur for a given thread. So we don't know when, let's say, thread T1 starts executing, but we don't know when it might be suspended or preempted by the operating system. Because of all of these uncertainties, the relative order of execution among all four of these statements A1, A2, B1, B2 is non-deterministic. So here are some example scenarios. The first possibility is thread T1 is scheduled first and it is allowed to run completely before thread T2. So in that case, the instructions A1, A2, B1, B2 would execute in this order. So A1, A2 would execute first, followed by B1, B2. The other possibility is that thread T2 is scheduled before thread T1 and is allowed to complete. If that happens, we'll get this order of execution among these four statements. The third possibility is that, let's say thread T1 is scheduled first, it executes its first instruction A1 and then it is suspended. After that, thread T2 is scheduled. Thread T2 also executes its first instruction B1 and then it is suspended. Thread T1 is again scheduled. And now it executes one more instruction A2 and it finishes. And after this, again thread T2 is scheduled. It also executes the last instruction B2 and it finishes. So here is the third interleaving of these four instructions. Likewise, there can be many different interleavings. So here is one more. Let's say thread T1 is scheduled first. It executes the first statement A1, then it is suspended. Then thread T2 is scheduled and thread T2 for some reason is allowed to execute both instructions B1, B2. It finishes and then thread T1 comes back and executes the last statement. The point we are making here is different runs of a multi-threaded process would likely result in different schedules, and therefore different interleavings of instructions across the threads. This feature, this non-determinism in concurrent programs or multi-threaded programs makes it difficult to properly test and debug them.